Okay, so now we're on to the final tool, foliage tool. So we've got the tree generator. Out the settings a bit. Recook. So I think I missed saying these in the previous tools, but I think it's important to say why the tool is necessary, or what it's going to be used for, why it was better to make a tool rather than just making a tree in, I don't know, ZBrush. I think trees is probably like one of the easiest ones to excuse for making a tool. It does take quite a lot of effort to make something like this by hand, and with the industry standard being speed tree, I think, and that not being an option, Houdini is a good way to learn kind of the procedural generation of trees and how it works. And then what I want to use it for was specifically so I could make trees to my concept. So I was able to ask a concept artist called Anya if I was able to use one of her scenes. I'm not sure if I've got it on my reference sheet, but I should be able to show something else. There you go. So here's a concept, and I think my main thought was it would be really cool to try and make the environment composition overlaid to the image so that I could draw the trees in the right shape in the scene. So you've got a spline option here so that I could get my pure ref, make it so it was transparent to my mouse, and then lower the opacity, and then I could just draw the trees into the scene. That was my main thought process. So that meant that this tool needed a spline input. It also needed tree variation. So with these ones, you've got a couple where they split off, and some where it's just one long trunk. So I would like that as well. And then it was a requirement for the tool to have a randomizer, and then I added some extra stuff to get this kind of like moss. And I wanted to make a moss generator that allowed me to basically build up moss on meshes so that I could make maybe some ZBrush sculpts like this and then automatically build up moss without having to hand paint the vertex colors. And it would be usable in like other sections. So let's get on with talking about this tool specifically. So let's look at the parameters. We have one input, and that is the spline. We then have our main options, our moss parameters, lichen parameters, bark parameters, and the wind mass maker. So main options: finalize render, bark variation, knots. We've got random seeds. We've got a style enumeration, which if we look here, we've got 0 as a large tree, 1 is a medium, and 2 is a small. Then we've got spline deformation amount. So this by default is 0, and then we've got a toggle to use a custom spline. So the spline deformation amount flow is something specifically for the larger medium trees, because they have their own bespoke splines that give them their shape. So the input spline, I'll get back to that bit in a bit, because it'll be easier to show you the nodes. Then we've also got the random branches. So random branches will randomize the trunk and the actual geometry branches, and then you've got randomized leaves, which will just randomize the alphas. Then we have the option, the toggle to turn on knots. That is a legacy toggle. We don't really need it anymore because I changed my method, but that spawns not geometry onto the tree, and the option is still there. It's just the outcome isn't very desirable, so I would say keep it off. Then we've got back variation, so that's vertex colors, and then we've got finalize render, and right now that's on, as we can see the whole tree with all the branches, but that that adds all of the alphas and it poly reduces the tree. So that is something that you use last. Then we've got our moss parameters. We'll go through those in a bit. Same with the lichen and the bark. We've got the wind mass maker, so I'll show you that later on as well. So let's talk a little bit about the layout. So we have large tree, that's red. Our medium tree, that is blue. And then we've got our small tree, I'll put that as green. And then we've got our atlas section, and I'll put that as yellow. So let's go through the yellow section first, because it's the most simple. We have embedded branches, so it's just all of the alpha cards. Then they go through a quick material, and then we use blast nodes to split them, and then transform nodes. It was probably an easy way of doing this, but this is just ways of me making groups of branches. And I think as a stretch goal for the degree show, I'm going to go back into these and make, because right now there's only 4 variations, so, and I could get a lot more variation out of this, especially with individual leaves being an option. Yeah, and so that these combinations come into these 4 generations. So we've got some with less leaves, some with more, and I think the main thing that I had to do was make sure that from any angle you can see some branch. This is probably the biggest culprit of that. So like from this angle we can see both of the cards, but from here we're not seeing very much. From here, but it's important that you can always see something when you turn around. You don't want that the cards disappearing. Now, another improvement that I'd probably want to do and have to test is having 2-sided foliage in Unreal might actually be more expensive than me just duplicating all of the geometry and reversing the normals on the duplicates. So see here we've got the normal faces back facing showing. So this blue black back face in Unreal won't be visible. So this branch isn't going to be visible from this angle. From this angle, this large branch won't be visible if you do not have 2-sided foliage on. Now, if I was to take this geometry and get the normals, plug that in, take a merge, plug them together, and then reverse normals. Yeah, it has worked. So now basically we've got 2 perfectly overlapped meshes where one normal's facing this way and the other normal's facing this way. So then when we load into Unreal, it does double the geometry of all the alpha cards, but it would mean that we don't need a 2-sided foliage on the material. So I'll do some tests with that before the degree show. So those merges, I've got them down here so that they can quickly be copied and then used on our tree leaf generator. So if we do this, so here, ooh, let's fix that. Maybe 3. Messed around with that by accident. So this tree generates geometry up until this point, where it then replaces it with leaves, and that's where we go with our atlases. This is following the Quixel tree examples, but I've realized now that they aren't optimized. Like they look awesome, but for a game ready asset, they're terrible in my Unreal scene. So this I probably need to come back to, and maybe doing full geometry without atlases and just leaf geometry and see how that works. But I've split it into sections, so we've got these leaves generate small branches at the bottom with not many leaves, probably because we've got like animals that are eating those, maybe deer from that height, and then we've got kind of like more leaves and more branches in the middle, and then a lot of leaves near the top, and then even more up here. Now this is going to be really bad for overdraw, and I need to make it accurately place them rather than just chuck a load of atlases in there. But in the end, the silhouette does read as a tree, which is the more important part. But it just it does need a lot more refining for the actual placement of and the variety of atlases. So let's go into some of the more technical parts. So we've gone through. We see that we generate a trunk, we generate branches, we generate leaves. But if we come into our switch node and look at the geometry spreadsheet, there is a lot of attributes that are going on right now that are being used, and we need to explain what's going on there. So let's go back to the start. We receive our curve input. In this instance, it is a turned over tree, and we make a curve U attribute. So that curve U attribute is basically saying how long along the curve are we, from 0 to 1. If we make the curve longer, it will still be 0 to 1, and then we take that curve U attribute and we make a wind mask from it. So see here, these values are returning 1. If we go down to the 0 value, the 0 values are returning 0. Now, this number is not just using the curve U value, it is also using the bounding box information. So, if I was to quickly draw a diagram, here is our spline, and we've got roots here. Then we've got our trunk, and there'll be branches along the way. And then this, I think this actually touches the floor. So when we're thinking about how the wind is going to affect this tree, we'll use blue to signify where it's not going to be moving. So this part of the tree, we have root networks that, depending on the species, stretch out at a very large radius. Sometimes you'll have them growing like 5 meters out from the actual base of the tree. And a lot of people think that their roots grow like this, and they grow downwards in a kind of upside down tree kind of way, like how the branches grow upwards but downwards, which is kind of right in some cases, but with most trees they actually fan outwards a couple of like within a couple of meters below the soil. So we've got a layer of soil here, they run along, and then you'll have I can't remember what the word is, but I think it's like a hang root. So it's like one root that goes straight down a bit further than everything else, and you've got kind of like some middle roots like this. So yeah, this part is very secure. We then go into our middle section, so that's here. Now we are going longer, we're going further along the length of our curve. So now the actual range from our stationary point is increasing. So we're gonna start seeing more movement, especially when we get to these higher points where you're actually gonna start seeing these branches, which are at the highest point of the tree, become very influenced by the wind. Yeah. So I just finished drawing this out. There you go. So now all of these bits at the end, they're all going to be red and very affected by the wind. And then you've got some tippity top points of the trees where they're also getting quite strongly affected because they are the highest point, whereas this is the furthest point. So we take both into account, and I think that's the reason I've got this example tree to show it isn't just a gradient from the floor upwards, it's actually a gradient from the origin of the tree upwards and along its curve. So if I had a curve that was a loop-de-loop, and you would still see that gradient all the way along that loop on the origin. So okay, let's carry on. We then take our spline input, and that is used by all three of our sections. In the small section is just used directly, and our tree is based off of the spline input if you click the toggle on. Now let's talk about that spline deformation amount flow. So these trees are made from, as I said, bespoke curves. So I got a reference and I was like, okay, I'm going to make this tree using the nodes, and then I'm going to make it procedural. So if we quickly just look at the outcome of the trunks of that tree, we've got this. So we've got a large, a medium, and a small, what are separate trunks but intended to look like kind of the trunk splitting into three. Now if I was to take my curve, how do I make it so that all three of these curves making all three of these trunks get this kind of direction without them just merging? So what we can actually do is get a distance along the curve. Yeah. Let's get our attribute spreadsheet open. And go into that attribute wrangle. So we have our wind mass still, we have our curve U value, and then yeah, that's it for now. Now we want to take the UV value of the curve, which is basically saying from 0 to 1 what the direction of the curve is. And then if I just quickly remind myself, so we have our conform strength float. So if you want to make something like that, you come into edit parameter interface and you add a float here, you give it the correct label, you give it whatever name you want, then I put the default at 0.5. Then that would show up down here, and if you want to reference that in your specs, you need to get CHF for float, and then in brackets the label of your attribute, not the name. So I've kept them the same just to make it easier on myself, but I could call this one like a long name, like amount of conform percentage to conform strength or whatever, as long as this is the right label. So this vex is basically saying we have two curves. So in this instance, we've got this curve and we've got the other curve. Now, take each point and move it from its vector location to the matching vector location of whichever point is closest along its length. So, see here we've got our position. Then we basically want to go, okay, well, visualize this. Yeah, okay. Let me quickly come out of the tool. That's why it wasn't showing up. Okay, there you go. So, here we're seeing our original curve move 0.3 conform strength to our, we're going to call this one the guide curve and this one the trunk curve. So, what's going on here is that we've basically gone, these points need to match up to their closest points on the guide curve, and imagine you have, let me do a little drawing. So you have 0, 0, 0 vector and a 1, 1, 1 vector. Now we're basically saying move 0.3 from here to here, which now means that this vector is going to become 0.3, 0.3, 0.3. That one's quite easy. But then if we've got, let's say we've got a 6, 6, 8, 12 vector, and we need to move it by a 0.5 strength to, let's make it easy for ourselves, 12 for 6. We basically are going halfway, so we're getting halfway between 6 and 12. That will now be a 9. I'll do it down here. A 9, 6, 9 vector. So we're going halfway, 0.5. But if that number was a bit more awkward, like 0.75, we would get a different vector, and that's what this code is doing. So it's just changing our 3 vectors basically, and that is getting applied to every single one. So see how they're still keeping a bit of their bespoke shape, but conforming towards the general direction of our curve input. So if I come back out and change this to be 0.1, now it's less so. Yeah. So I'm going to leave it like this and go through the rest of them. So I would like to point out that this section was copied and moved over here as well, just to make a second variation where I've made a larger tree, and that does a similar thing but makes a much larger combination. But all of these nodes are the same. They just have different parameters to make a different looking tree. So now we take our new curves and we plug those into 3 different trunks. We then rotate them in a way that means that we've got our shape here. It's cool. These middle nodes were just copied from the original small tree, so they just add branches, and then I edited them a bit, so then we end up with the branches generating like this. Looks like they're using the wrong object merge. See what that final, yeah, it looks like they're all using object merge 4. Let's see, 4, 3. That one's also using 3. Let's grab a more bushy tree, bushy branch, and bring that over here and swap that out. See how that looks. There you go, that's better. So same logic, less leaves near the bottom, more leaves near the top. Now let's go into bark variation. That's the next important bit, I think. So if we look here, we have our bark variation. So during my formative session, I showed some references from Bradgate Park, and at Bradgate Park you have these very, very old trees. I'll see if I don't think I've put them in the PureF, but they should be some trees around here. I can follow that reference. So what I was looking for is basically parts of the tree where the bark has been stripped away due to whatever happened. Sometimes it might just be a little bit of damage to the tree that then becomes bigger and bigger and bigger. I don't think I can find any references. Let's look up damaged tree. Okay, so I was probably aiming for something like this, where you've basically got the different trees react differently to this kind of damage, but you've basically got exposed wood, then you've got the bark, and then you've got this middle layer of kind of depending on how fresh the cut is, it's either just the inside of the bark or it's this kind of bulging looking younger bark where it's like healed the gap here. So this bark is more closely resembling the bark on the younger branches, again depending on how old the cut is. So we come back into here, you can see that we've got the red, which is our new exposed wood, and then you've got the blue, which is the young bark, and then also we've got this green section, which I'll quickly show, which are like tumors, I guess, on the tree. So parts where the tree started growing a little bit out of control and just get some more like surface variation. Let's see if this terrible photo. There you go. So you got like a really big one up there of just growth on the trees. So that's what I was going for with that. Now all of these are controllable. So if we come here and go into the bark, we have, there you go. So all of these which are referencing my channels of my parameters. So if we look here, we make floats that we can then reference in the Vex from our channels. We then make our R and G float values from whatever red and green we already have, and then we're making our final vertex color at the moment 0, because right now there shouldn't be, back here there was no vertex colors. The thing about Houdini is if you've got vertex colors on your mesh, it will just show you them. So this isn't me visualizing the vertex colors, it does it by itself. Probably a toggle option that I could use to turn it off, but yeah. So we've basically gone through and we've removed any CD values, so any vertex colors that might already be there, and then we've made a X CD, because CD is a vector. So here, if we find CD, green and blue and red, red, green and blue, so this node is setting X, which is red, and it is just giving a random float based off of a noise that we can control the amplitude of, and then that becomes our red color. Now we'll see that here it does make basically the whole tree look red, and that's why we've got some extra lines of code in here to kind of clamp those values. But you can see this is like a darker red and there's a brighter red there, and then we add our green values, which is making a lot of yellow, but we'll also clamp that, and same logic. So the amplitude is exposed, we're doing it on the y-axis. We haven't actually got any blue because if you remember, we make the blue in this attribute wrangle. So let's go through it. We have an integer callout for our branch level. That was added later on because the moss displacement and all of the displacement was giving the same displacement here to all of the points, and it didn't. So when you've got really thin meshes that are going inwards slightly, they'll end up just caving in, which isn't what we want. So we've called this integer branch level value because you'll see here branch level, so 0.0 is on branch level 1, and if we scroll down it becomes branch level 2, branch level 0, branch level 1, branch level 0. So if I remember correctly, I think branch level 0 is the trunk and branch level 1 is the first set of branches, and then so we use that integer. Now we're setting the red displace and the blue displace to 0, and then we set, if the branch level is 0, then the displacement amount is just what we tell it to be, and that's basically saying on the trunk the branch level strength doesn't affect the displacement. Now we then have our red bark displacement. So we've got our core threshold. So our core threshold is basically, I think it is how far the red spreads. So if we just alter that in here, so as we increase this value, it makes the red, it makes the blue come in, or the red go out if we go the other way. And then we also have our outer threshold, and that is the blue going out. The blue will never go in to the red from this one, but we can control how far it goes out, and that's really good for adding variation to the tree. So again, we reference the core threshold here. So if R, which is our red value, is larger than or equal to our core strength value, core threshold, did it say? Yeah. Then our final vertex color is completely red and no blue or green. So that's what's clamped our red value to be just red here. Then we displace the position of those points using the normal information times by our red displace, which, because the branch level 0, that is just gone in by whatever we've set it to be. So right now it is set to minus 0.01. So I presume that that's centimeters. And you can see here how we've got a little bit of an issue where the displacement has actually caused them to cut into each other. So we can make this even lower to fix something like that. Let's get back to here. So then else if r is bigger than or equal to the outer threshold, so that is where it's blue, the final CD value is 0 red, 0 green, but 1 on the blue, and then we displace those points by the blue. So this section is setting the vertex colors, and it's also displacing. Now the green displacement, so that is always applied evenly to the branches because it's an outward displacement, not inward. So there's not really that many issues on these smaller branches. It just makes them bulgy. That's fine, especially when you've got the branch atlases and you can hardly see. But then we take our mask float and we're setting it to be a clamp of our G value, which we've already set up here. And that clamp is made with our green threshold. So if we change our green threshold now, you'll see that clamp we can push up and down. So this is basically a fine way of controlling where our green that was here, basically all over the tree, becomes just a little bit. Yeah, and then we divide that by our 1 minus green threshold, so that basically clamps it to this small area. Then we displace. This one's quite an easy one because we don't have any setting of different vertex colors. It's just clamp the vertex colors out already there and then displace. Then we can smooth fade it. That one is just smooth fade. We can increase it to like here, and then let's displace it more, and then bring down. We bring down the sharpness, we'll bring it up. See, because this is all working off maths, there are some combinations of float values that will end up giving you quite similar results. But this that we've just changed is still quite similar to what it was before. So, but I think these nodes are quite optimized. So even if I did get rid of those options, it wouldn't really make much of a difference. Then we need to actually set the mask because we're setting this final CD value on all of them. So we're basically just saying that this part is now green, and if we faded it, it's this fade float value that we've made, and then we output our final CD. So that is the bark variation, and now I've used my red, green, and blue channels, which now, if you're familiar with the Quixel trees, they use red values for their wind. They use blue values for their wind, which means that I've now burnt those bridges on being able to do it in the same way that they have, which means that I need to find a different way of doing the wind, which I'll go into in a second. But now I also want to add moss and lichen, but I don't have any more vertex colors to work with. But I can combine vertex colors to make yellow, cyan, and magenta masks. So right now we've got anywhere that's black, green, red, and blue. That's 4 different variations. We can add cyan, magenta, and yellow to get that up to 7. And then if we really wanted to, we could push to 8 by having white. That isn't really necessary. So let us see what this makes. So this is adding our moss, you can see there, and then it's also clamping all of our vertex colors. So The reason it's doing that is because when I go into just that counts as a trunk. That looks silly. Okay, so here the red value hasn't really changed because they didn't have a fade option, so they were already 100% red and 100% blue. But then the green had a fade option, which we've had to get rid of now, because if we have let's say a faded green and we have a point where you've if I quickly draw this again, so if let's say we've got this point is red, fully red, and this point is 50% red, this point down here is let's say fully blue actually, and this point is half blue. We've got like a fade going on, and now this point is also half blue, and this point is half red. Now we've got a magenta value and another magenta value here. Now that wasn't purposeful, they've just bled into each other. So if I then wanted to specifically set magenta to be, let's say, moss, anywhere where red and blue are close to each other, we're gonna get moss, which we don't want. So we have to clamp these values to basically say you can't have any halfway values. There can only be one, or if they are two, it's because they are moss. So I specifically chose yellow to be moss because we do get magenta here, and that's going to happen basically anywhere where we've got this blue edge. So yellow was kind of like yellow was the least common color to happen accidentally, and then magenta for lichen. That's because I didn't exactly plan on using lichen that often, but I did want to still add it because you can see here we don't have any magenta values because the lichen is set to 0. So let's just go from here. So we make our occlusion values. I think I went through this in the house already, or the sign, one of them. So we make our yaw and pitch values. I'm not going to explain this math again, it is in a different video. And then we go through here, 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 and then this is where it's different from the Moss HDA that I used for the sign for the house. And that is because we need to set absolute values. So we need to say if the grunge mask, which is cyan, is larger than 0.1, then set the CD values to an absolute of blue and green. RGB, yeah, green, blue. Lichen mask is magenta, so red and blue. And then we've got moss mask is red and green, so that's yellow. And then we've already got the absolute values for red and blue. So that those are left unaffected. And now that gives me these really harsh masks. We've also got displacement. Now what do I do with these? We take them into Unreal, and there's a little bit of math that you have to do to get these values. But if I quickly explain it here, think. So let's say we want to get a mask which is just yellow. Now in this case, yellow is 1, 1, 0. And then in Unreal we have our red, green, and blue outputs. And we only have these outputs that we can actually use. So how do we convert these masks into a mask that only shows yellow with no other colors? Because if you think about it like this, if our setup is, I wonder if so if we have, oh, yep. Okay, cool, good enough. So if we have a green value here, when we take this green value out in Unreal, this area will be completely white, and everything that isn't green will be completely black. But our yellow value is going to come up as white for the green output and the red output, because it's on both. And then it will come out as black on the blue output. So if I'm saying that I only want the parts that are 100% yellow, and if I make a second circle here that is 100% red, I want to be able to drag out this red value and only have red. And I want to drag out the yellow value and not have this bit involved. I hope that makes sense. So the math that we do is we get a step node, and we basically say any values, like clamp it to any values that are above 0.5 of red, and multiply that by any values that are above 0.5 of green, and then we multiply that by a clamp value of anything that's below 0.1 of blue, and then that basically just leaves us with what is 100% yellow. I hope that I showed that in my breakdown of the Unreal scene, but that would leave us with just our yellow values. We can then like mess around with that mask, like we can blur it a bit, we can give it like an edge of noise so that we don't have this hard step going on. We've also got a little visualize here, so this visualizes the moss in a more like organic way, and then these are just some old nodes where it didn't work like we wanted. So this is just where these are previous experimentations where they didn't work. So this one didn't work because the like the masks responsible for displacement were displacing the whole mesh, and then that's when I added the branch integer option so that we could make it displace less on the bigger branches, and then also restrict itself to the mass points. I think with this one, why did that one not work? Can't remember. Okay, it didn't set our moss mask. What about this one? Same thing, moss mask didn't work. So this was our finalized node. We can then come out, and that is going through a switch parameter, which is controlled by a bar variation toggle. So like that, these options won't come on immediately. Yeah, this is making sure that our values are absolute before they go into the moss mask. We then need, okay, yeah, so wind mask. So we're using red, green, blue. We've got our yellow being used. Our magenta is being used if we've got Lichen. And I was like, okay, maybe I can still use the cyan for the wind mask, but then I'm not going to be able to get a gradient, which is important. So how do I get a gradient? Well, we still have second UVs. So we keep making the wind mask, and if I get the visualizer, so this visualizes the wind mask. If I plug it in here, So this shows purple is 0, red is 1. So we can see at the tippity top of our tree we've got the most wind. We got no wind down at the base there. And then if we plug it in to our foliage, we can see that every branch receives the wind mask data of the part of the branch it spawns on, and then we have an option here. Yeah, so this was me trying to make it so, because like with this one in particular, this is basically not going to move in the wind, but then you've got like the ends of the branches which logically should still be moving because they're thin branches. So I thought if I can get the bounding box of each atlas and then make it so the top of the atlas has its own fade value. So if we're able to bring that down, there you go. So remember, more towards red means it has more wind applied. But you can see how now we've got a different color to the branch that they're spawning on, which means that we haven't got like a nice fade, and we really need these two values to match. So I think if I take it like too far, we can actually end up having branches that move slower than their like the atlases that move slower than their branch. So let's see if we can find a value where the actual fade is present. It could be that this node isn't actually doing anything properly. Oh no, you can see it. So as we're getting to the end of these, they're slightly higher numbers. So this is like purple, and as we go up, let's follow this one. Purple, purple, and that's a little bit more blue, 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 blue. You can see that. I hope, fingers crossed. Then you've got branches like this. Yeah, with some of them it hasn't worked, just the same, but okay. So this tree will be heavily swaying near the top, which is cool. And if we try and show that spline input tree instead. Ice cream truck. Here you go. So you can see how we've got purple near the bottom, and then as you go up, it's getting kind of darker orange here at the top than it is down here. It's darker, or well, more red. And then here we're further along the trunk, but it's actually more yellow, and that's because it's taking the height into account as well. And then we've got the strongest part, which is down here on the floor, and then so this would probably be rubbing kind of like across the floor, hopefully, which would look pretty cool. But it also actually might just go like into the floor even more, depending on how the tree's rotated. But yeah, so I'm not going to go too much into the large tree. I'm just going to show you what it looks like, because this one is the one that needs like the most input to improve. Oh my god, it looks even worse when it's using the wrong branches. I think, I'm not sure why, but the object mergers got changed. So if we just quickly grab the right one. And let that reload. So yeah, this is just a really noisy tree, which I guess if you're like underneath and you're looking up, ignore the tiling. This is just a placement texture that has even more tiling than it should. Like, I think if you're looking up like here, maybe it wouldn't look that bad, but from a distance it's very noisy. The overdraw is going to be insane. So this tree definitely needs improvement, and this was just to show, this was just to get the logic of the style choice working, so that I could go back and improve the tree if I wanted to. But yeah, and the deformation should work the same here. Yeah, see that might be an alright generation. But yeah, that's not that bad actually. If you wanted a oddly bent tree, which as it is very art directed, I could have like a I could have one of my big spirits like leaning on the tree, hugging their knees. These are feet. And I guess that could make sense. Okay, yeah, that is basically it. And then once you've got your generated tree, you can just save it as a FBX if you're working in Houdini. But this will also work in Unreal. So thank you for watching.